All right, guys, I want to continue on the lecture about energy expenditure equations. We have the ACSM walking equation, which is going to be any speed from 1.9 to 3.7 miles per hour. Anything over that, we're going to use the running equation for. Um, these are just given miles per hour examples based on being able to continue to have 2 feet on the ground at a time. So that is why ACSM came up with that. These are their given equations. We aren't going to change these at all. Again, as I said in the last part of the lecture, if you are not a math person, take this slow, pause if you need to. One thing you really need to make sure you focus on is doing these equations in their individual brackets, okay? Making sure you solve. I put the different parts of the equation for ease for you guys in different colors, okay? So you would figure out everything in the blue before you add it to the red and the green, right? Use your order of operations math class information here, okay? You are given the walking equation from ACSM. One constant that I do want to let you know is that 1 mile per hour is 26.8 meters per minute. You are going to have to use that conversion. Okay, so again, here's our walking equation. You will be given this. I don't ever expect you to memorize this, okay? Maybe in some of your other classes you will, not for me, okay? Again, I put the 3 parts of the equation in different colors. We have the first part, which is the given constant, which is Met level, or just METs, 3.5. This remains, okay? That's going to be the red part. Then we have our walking speed in meters per minute times 0.1, okay? We're to solve for that blue part next. And then the green part is going to be walking speed again in meters a minute times your grade. Sorry about that. Times your grade as a decimal, and then your another given constant here. Okay. So let's just do an example together. What is Emily's VO2 during her walk at 3.6 miles per hour and a 3% grade? So first we need to convert our miles per hour to meters per minute. So we're going to take 3.6 miles per hour. We're going to multiply that by our constant, which we know, 26.8 meters a minute, and we get 96.48 meters per minute. So that is now her walking speed that we will use here and her walking speed that we will use here. Okay, we're going to convert her 3% grade into a decimal. So 3%, 3 divided by 100 is 0.03. Okay, it's a pretty easy one. So again, 0.03 will go here. So after we plug in those numbers that we just determined into our equation, it will look like this. Okay, we are going to solve for the red. There's nothing to add or subtract here, so we just bring that down. Next, we are going to solve for the blue. So 9.648 times 0.1, we get 9.648. And then we solve for the green. So 96.48 times 0.3 times 1.8 gives us 5.2. Okay, then we simply will add those 3 things together. Again, the red, the blue, and the green, add them together, 3 parts of the equation to get the walking VO2 of 18.3 milliliters per kilogram per minute. So we know this is Emily's VO2 during her walk. Okay, you're like, why do I care about her VO2? Well, we want to know her VO2 so that we can put it into that total energy expenditure equation, right, that we just talked about. So we will do a full example on the next one with the walking, but knowing VO2 is important. Here's a running equation. Running equation is almost nearly identical. There are some of the given constants are a change is a 0.2 and a 0.9. So you are going to do this exactly the same way as we just did that walking equation. The equation is different, right? But it still has three parts: the red part, the blue part, and the green part. We know our miles per hour to meters per minute. And we also know how to convert grade to decimal points. So that's exactly what we're going to do. Ryan, what is Ryan's VO2 during his run at 6 miles an hour and a 4% grade? Well, we know he's running at 6 miles per hour. We're going to multiply that by 26.8 to get our meters per minute, which is 160.8. We're going to convert our 4% grade into actually 4%. So 4 divided by 100 is 0.04. And then we just plug those numbers in. We now know running speed. We're going to plug that in here and here. And then we know grade. And we're going to plug that in here. Okay. So again, solve the blue. We get 32.16. Solve the green. We get 5.76. We're going to add that to our constant that is in the red that has stayed the same. And we know that Ryan's VO2 during his run, after adding these three values together, will be 41.42. Let's take it a step further of why do we care? Okay, VO2 is going to allow us to convert activities into METs, which allows us to solve for caloric expenditure, just like we did before. Okay, so if we know that Ryan's VO2 is 41.42 milliliters per kilogram per minute, we know that one MET is 3.5 milliliters per kilogram per minute, right? So if we take Ryan's VO2 and we divide it by 3.5, we are going to get the MET level. Ryan's MET level of his run was 11.83. We knew his VO2. We know, this is a given, that a MET is equal to 3.5. So if we simply take Ryan's VO2 during his run, divide it by 3.5, which is one MET, we will get his MET level. Okay. So the only thing we need to know now is really how much Ryan weighs in order to determine how many calories he's burning during his running exercise. Right? His VO2 was 41. His MET level is 11.83. Okay. So let's just say Ryan weighs 150 pounds. We know that we're going to take that 150 pounds, we're going to get it into kilograms. So we're going to divide by 2.2 to get 68.18. Then we're going to put it in that total caloric expenditure equation from the previous part of the lecture, right? 0.0175 kcals a minute. His MET level, we know it's 11.83. And his total body weight, which is 68.18 kilograms. So we're going to get a total of 14.11 kcals a minute. In his 30-minute run, we multiply it by 30, and we get 423.45 kilocalories that Ryan burns during his 30-minute run. Ryan's 30-minute run burned a heck of a lot more calories than, what was it, Betty was our example. Betty's 30-minute walk that burned 130 calories, right? We would expect Ryan's run to burn more calories. Why? Well, it's a higher MET level, right? The higher the MET level, the higher the caloric expenditure, right? The higher the MET level, the higher amount of intensity that we are using, right? Ryan also weighs more than Betty. Betty only weighed 130 pounds. Ryan weighs 150. So not only is Ryan exercising at a higher intensity, his weight is higher, and the mass that he is moving through space to run is going to automatically burn more calories, right? So this is why we want to be able to take our clients, we want to be able to take an example, take it from start to finish of how many calories is my client burning? How many calories is the soccer team burning during this workout? How many calories does so and so need to burn a day in order to be in a caloric deficit? And what exercises can I recommend to him or her in order to be effective in that? Okay. That is the end of this part of the lecture. Again, rewatch the lecture several times if you need to in order to kind of go through those examples and feel better about your math part of this chapter.